All right, welcome to the February 1st. It's come up fast. Now we are deep into the build season with the DiscoBots, and we will be talking in detail of CAD. We did some good testing on Saturday of the intake and of the spindexer and some good April tags testing as well. So we're making progress on all sides. But one thing we didn't do a lot of progress on because we just had too many other things to work on is the shooting mechanism. We're gonna dig deep into that with Levi right now in CAD. So kick it off whenever you're ready.
Yeah. Okay. Okay, so like you said, I think on Friday I added these standoffs because we had some extra space uh, over the drivetrain because this plate is where it connects to the drivetrain, and then we have like another inch, so out of that inch, put in these plates and these standoffs, so that should add some more support. Subject and Dirk were telling me to use like angle pieces to connect these plates, so I can just put like four here, and then the plate on this side would just be Lexing that would bend that I can do zip ties, uh, which is not terribly important right now because what we're wanting to test is the shooter, not the indexer. So for now, like I can bend these plates and then just push the ball up with my hand, and then once we have the shooter part done, then go on to the next one. Yeah. So
I don't think it hurts to have standoffs though. So even if you want to add some holes, um, maybe in between the indexer rolls, just think about how we can make this thing really rigid because
yeah,
we don't want it shaking too much. So even having just some holes there, if we use them, great. If we don't, they're there. So
yeah, I can put some holes like behind these rollers for insurance. Uh, but I try to make the plates like instead of having this plate and this plate and this plate, I just have one big plate that can fit all. So that'll make it a little easier for cutting, so I don't have to cut so many plates and or overstay a little more acrylic. So and then I don't have the motor mount, so I can do the vortex here for the 1-to-1 ratio. We were talking about Saturday, that may not be enough because looking at WCP and the Spectrum did Krakens, and they both did more than one, so we may need to do a gear ratio. So I have the holes for that, and if the gear ratio doesn't work, then we need two motors, then I can work that, so we can add that in. I do have the holes here, so we can always just put another motor on this side. We believe we have the space for that, so we can also do that. And then you have your hood parts, and then just a 3D printed back that's a little more solid than just a Lexan plate. And a little easier to like control the angle all the way through, so I'm not having differences in compression as the ball's shooting. So I think that's about it.
what's the distance? I don't know if you check this from the shooter wheel to the final indexer wheel that would hand the ball off, because I think that distance from roller to shooter wheel looks different than what I see in the WCP. So
It probably is different. It's about a 2-inch difference in there. I actually looked today at adding another wheel like higher up, but to do the shaft all the way through, we'd have to do it here. Um, and then if you do that, the compression from the back wall to the wheel is going to be 4.4 or less, and you don't want that. Like that much compression on the ball because I can't fit another wheel here, and I don't want to move it over here because then it's too much compression. But the distance is not too much, and the wall is pretty consistent all the way up. So.
So if there's too much of a gap, the ball will just spin. Does that make sense?
Yeah.
So it's almost like a very momentary ball is touching the indexer, and then it immediately touches the shooter. There shouldn't really be a lot of gap. So I would look carefully at how WCP did it and figure out if there's some way for us to do it as well. I think we have smaller wheels, so if you're worried about maybe getting something a little smaller, we could maybe go that direction as well for that final indexer.
So I don't know if we have small too.
What are the
move all the axles up?
What?
Can you just move all the axles up a little bit?
I could. I don't know if that'd be enough room to add another one down here because it does need to be towards a certain height. Otherwise, ball can actually get in. But yeah, I could just move it.
You'll also need rollers along that curve at the bottom, or you need a roller like where concentric to the curve, if that makes sense. So like you need a roller on the other side, so when they get out of the spindexter, they still move forward without having another ball behind them. So it can fully empty, if that makes sense.
Yeah.
Yeah.
I think you could also use our intake rollers, the Versa rollers. Those are an inch and like a quarter, I think, on the OD. So if you want something strong, we can use those.
Okay.
Yeah, I mean we have 2-inch wheels, but I encourage you to really look at WCP, and if we can match their index location, whatever it is, the center of their last indexer to their shooter wheel, we really need to look at that geometry because it's going to save us a lot of testing because they've already tested that. So let's really study it. So
Yeah, I did.
okay, and then same goes for how we're going to pull in the balls from the spindexer. You know, this when it's mounted to the spindexer, we should be able to test it pretty quickly. Are we flipping the shooter the direction over the climber? Is that
I actually asked with Cedric earlier. It's as we have it now. It's here. We could at the height it is. We could just flip it over. We may need to make a column depending on what copper it is and how many balls we hold. But I mean, it's not really that big of a deal. We can just do that. I mean, I think as we have it's probably good because we're already going over the bump on this side. So we go over the bump and then we can just go. If you're looking at a top view, you go with the bump this way. You pick up balls this way, then you can come back over the bump, and then you're already on your shooter side. So you have to do like very minimal turning. Something. This is, I mean, where we have it's probably good.
the only thing I worry about is somebody could block us. If that makes any sense, like a 30-inch tall robot and getting right next to us, they could cause us some problems.
Yeah.
But if we are shooting over the climber, then we won't have that many issues because the ball will already be well above anybody who might block us. So.
Yeah. I mean, it's not hard to change. So if we want to go that direction, that'd be pretty easy to get.
I like that better than the direction we're shooting right now. That's just my thought process. So I don't know, Cedric, what do you think?
Yeah, I think I agree with that. I think we can definitely just flip it, and it shouldn't be too big of a hassle.
It actually might make your indexer thing line up better, because then your shooter wheel will be right along where the indexer needs to be to take it in from the spindexer. Does that make sense? Because if you just did a 180 with that and then just change the slope geometry, then you're actually going to be intaking it with the index wheel facing the spindexer, which is probably easier to design anyway. So yeah, all right. Cedric, you want to go next? So.
Yeah. I think for the shooter though, I think we could probably just like try if we're sure about at least the last two, like the shooter wheel and the last indexing roller, can we just like cut that and just test that? Because I think at this point we still just like we need to test it. If it's close enough, if it's like any sort of like close or okay performance wise, then I think we can build on it. But right now I don't think we have much to work on shooter wise. So
Yeah,
I think it's
hopefully,
good.
hopefully Lamar can do at least some of that on Tuesday.
Well,
And then
Levi, make sure you give them a file that's maybe like cut in half. So what Cedric's saying is just like the top index wheel and the shooter. The other stuff you could just basically cut it and let Lamar make that smaller plate, and that can be just tested. You see what he's talking about?
Yeah.
And that could work actually for the indexer from the spindex, because we could literally just take any sort of plate. We're just looking for one wheel that lines up in the right place for the spindexer, and we could just test that as it comes off the spindexer, and it doesn't have to go anywhere. It's just a wheel that pulls in balls. So, all right, Cedric, your show.
okay, so I worked a lot the past 2 days over the spindexer. This is the version that got used at Lamar. And from what I heard, and the spindexer, we basically decided Friday that we kind of just want to be able to take it if we need to, like unscrew a couple bolts and lift the whole thing out. So that was the design intent behind this whole assembly, is that the only thing that really attaches to our drivetrain is this piece of tube, which has end caps at the end of it. So we can just screw it in. It's 6 bolts to screw it in, and then when we need to take it out, 6 bolts to take it out, and we can take the whole thing out. It's basically just a floor with a center roller that's powered by this Neo. We plan to use the rev brushes with the compliance star. So yeah, and we also discussed that like I don't think it matters how many balls and spindexer can hold. We thought it was much more important to just make a spindexer that could pass balls through quickly rather than how much it could hold. So that's why we went with 3. Also, the rev brush hubs just also come in 3 or 6. So there's that. My initial design was to do something like this, where we have a big flat circle supported by a bunch of churros, but it turns out that apparently broke immediately. So I think it was fine as a temporary quick solution, but I think eventually we're getting something more robust. And from what I've heard, a little bit of extra tolerance also wouldn't hurt. So what I worked on today was a second version of this. The tube itself is still the same, so we won't need a custom machine a whole brand new tube again. Unless it's for a spare, of course. But essentially, this idea goes back to what looked more like the crayon cat, where we have just one piece of plastic that can wrap around the whole way. And then I was discussing this with Carl earlier today of how we're going to secure this. I think there's many different ways to do it. One way is, my initial thought was to do this sort of churros into the floor, and then if we have enough of those, and we zip tie the curved part of the plastic onto the churro, it would constrain it. But a more robust solution was to add a couple, probably like 5 or 6 of these aluminum angle pieces. This is just like Versa frame angle, and so we can add them between the churros to really secure them to the floor. And I think an idea like this is very possible. And I think it would be more robust. Another thing that I showed this on Friday.
Quick question: is that
Yeah.
circle the same that we've already cut? Same geometry?
The floor.
Yeah.
The floor is bigger now
Oh, okay.
because I heard you guys need more tolerance because it was a struggle. So I
Okay.
think it's fine for now, but for the future iterations, I just made it bigger. But I think the design that I think is a good template, I guess you could say, is something like this. This is from the Rembrandts. They have a pretty similar indexer, honestly. I think the really big differences are these curved pieces. And I think their floor actually spins compared to our floor that just stays without spinning. It's definitely something we should consider. Like, something that I think we need to figure out soon is how we're going to actually attach this bent piece of plastic to the floor. But yeah, so I think this has been kind of my idea. Where I've been getting my ideas from was the Rembrandt's build blog because they have a lot of information on the spin mix and stuff. So yeah.
From testing it on Saturday, it's working pretty decently. I think what we're going to find is that some of these improvements are going to make the balls per second go just a little bit faster, and we won't have as many like hiccups. But in the end, it's going to be a stream of balls, maybe a couple hiccups that will delay the stream, but we're still going to move balls pretty quick. So I'm not really concerned at this point. We got to really just get everything together. That's the big one. So
Yeah.
I wouldn't let yourself get slowed down from like the whole CAD by just thinking about all the ways we could improve this, because it's working decently out of all the prototypes we've done so far. So just, I guess it's a note of don't stress about it too much. So.
Yeah, and actually, I do like the 3D printed, connections on the inside, and that's not a bad connection. Just on the black pieces on the bottom, just because it wouldn't get in the way of the ball. Yeah.
I think even in a design like this, we would probably still add we cut top part of I guess that's not an important detail right now. But we would cut the same circle piece that we did this past Saturday and just mount it on top so the chillers are supported. In terms of the whole robot CAD, we also discussed on Friday that we thought one motor is probably enough to actuate the intake, and we decided that I haven't gotten the chance to make the change in CAD, but we said that we think just running a shaft, because our whole idea here was how can we make sure both sides are actuated at the same time and are synced up. At first we were worried about ball path, but we decided that based on looking at how the intakes have worked, not ours, but looking at like WCP's intake, it looks like the balls actually got pretty high on the bumper compared to what we have. So we said that it may not be a bad idea to just run a shaft through the whole pivot, and so we'd have a pivoting side here with a shaft that goes all the way through, and then it would just be connected to this linkage via a hub of sorts. And if we have issues with ball path, we'll just find a way to make the ball path go above the pivot and into our hopper that we're going to make.
Well, if you look at that angle you just had, you can see where the spindexer is. So the shaft looks like it's clear right above the spindexer. So as it's spinning around there might be a few issues, but I think that's probably still going to work. So And we've got enough of these pieces here where we could literally put this spindexer with all the mock-up of the intake, run the spindexer with a drill with a bunch of balls, and see if it jams up on that shaft that's running through the robot right now. Does that make sense?
And then for this intake, what do we want to do about? I know we had a pretty big discussion on it earlier today. What is the plan with these rollers? Because I know the sub rollers are like unreasonably expensive. I look prices and they're unreasonably expensive, and I know that based on what we have the 18 tooth custom pulleys that we printed for Crescendo. I have like another huge bag of them on this side. So do we want to design going forward using those and then just stick with them, or if that goes well, go and get sub rollers, or like what's the plan here?
I like the 18s because we're not getting too much bigger than the roller itself. I've seen some balls get chewed up by things that, like a pulley or something. So I think keeping it lower than the roller is pretty good for us compared to going slightly bigger than the size of the roller itself. And since we already have them, we can test it pretty quickly.
Okay.
And we'll note the Crescendo ones like to break right where where the pulley meets the rest of the roller. So you might want to consider a design change of the pulley anyways if you want to reuse the SLR design. They break a lot. Like we had a lot of those issues in Crescendo, and we didn't even cycle that much during Crescendo. If we're planning on cycling hundreds of balls, then I feel like they're going to break a lot, especially with this length of shaft.
Where did they break?
So
they
like
break right, they break right where, because these were custom, so they broke right where the end of the pulley tooth met kind of the rest of the hub. So like if this was, I wish I had it open, but if like this was the hub, it would break right at this point. Basically, it would just kind of shear off on the layer line, because I think we had a batch that we printed straight up, and so it sheared right along the layer line, and all of a sudden this roller just didn't spin. So I think our solution was like we electrical taped it for a match. Yeah.
But isn't that just like a material problem? Like we might have just printed with something that was not filled in properly.
I'm pretty sure.
they're 100% on everything.
100% fill?
Sid used like PACF at like 100% infill. So
We actually turned away from PS. We tried CF at first, and then we realized the CF had more shear. They sheared more often, so we switched away back into like I forgot what we used less. It was some PLN.
Yeah, PTG, C or whatever P. It's I think it's ETG, but it's a copolymer or copolymer.
The main issue we found with these rollers was since the torque went through the 3D printed piece of the pulley, they would shear right when the torque had to transfer, basically. The reason like the Grasshoppers one and the other ones that were successful is because these 3D printed pulleys went above the roller, so that they so all of the like rotational force didn't go through the layer line.
Yeah, and at first it was very thin. The wall was very thin there, so there wasn't much area right in between the connection. Because there's a shaft in the middle, so you have to make it. There's a maximum size you can make it, but it was very thin at first, and I think they did.
Well, that's an option then. We just go on the outside. I think that's a pretty easy part fix, because then we could just thicken it up on the outside and still.
Yeah.
We could even make it like a little slope to it, so we don't have to worry about the balls kind of getting pulled into the pulley or anything. They could have a gentle slope, so it just forces them back into the center. So
That would work. Yeah.
Okay, that's good. That's a good call. But I think we can still test with these ones that we have.
Yeah.
We just got to know that they're gonna shear unless we
No.
redesign.
I think if you even use the right like belt, you don't even have to change center distances. You can just change the belt depending on what you use.
Let's talk about live axle versus dead axle. I realize that we could do everything dead axle because all those things have bearings in them, and then the dead axle would actually be the standoffs between the plates to stiffen them up.
I honestly think with dead axle, I think this is a good place to try a dead axle. So I think I'm also fearing with these bearing holes. I mean, I guess you would really be like, but I think with the bearing holes, we would need to make a sandwich on each side. So we'll have like, instead of just this one plate, we'll have a copy of this on either side. So we'll have like 4 intake plates on this one intake, and I think that'll just make it more complicated compared to a dead axle.
We essentially prototyped a dead axle, and it wasn't really built out right. But I think we could easily build that with everything we have and prototype it pretty quickly once you give us the holes that can handle 60 tooth belts. Because right now
I think these are. I think I already made that change. I'll look at it again. But once it's done, I can send it to her.
any other thing, Levi, you remember from testing this? You're the one that built a lot of the hardware.
I mean, personally, I kind of like the dead axle or live axle. I was I copied what Cedric had done, was working with that. I think that
But
how you have the spacers and whatnot are very very flimsy. I think there needs to be a lot of changes to like how you connect the plates together because it's like if you just grabbed it from the side and moved it back and forth, it was shaking pretty badly.
Yeah.
Something like either hex or sure it doesn't matter all the way through on each of the rollers would help somewhat, but then also your connection point at the plate that connects to the drivetrain should be beefed up. Your where you have your big sprocket was probably the strongest part on the intake, because you don't have any of these small holes in spacing and whatnot. But the smaller bar was pretty bad. So
my vote is we need to add some holes anyway. So I would put a few different test holes around these intake bars. So if we decide we want to change something, we have options. I was also concerned about how it sits on the bumper. How are we planning to rest on the bumper?
What do you mean? Like, how are we?
Like when it's down, it kind of touches the bumper, but like, yeah, see the bottom 4-bar linkage? It doesn't really touch. So there isn't anything holding it up except for kind of the motor's force, and it's not.
Well, my plan was eventually is to design some sort of just like mechanical hard stop in a way, so that like you can just like not put all the force in the motor. Or I remember I think someone said on Friday to put springs between the 2 linkages. Thought that was pretty smart for. I guess that's for rigidity, but I was eventually planning to like make the same sort of hard stops that I had on the original intake that I made. Maybe in a slightly better manner, but have a hard stop like that to where it's hard stopped in 2 directions, so we don't have to worry about it.
Josh,
That's sort of, I think
go ahead.
the important thing is they need the hard stop to test it because they don't have anything to know where it stops right now.
Okay.
My advice, if we're gonna just make these intake plates, just throw us some holes, kind of right below the blue linkage, on the intake plates. So we have that top blue linkage, that hole. If you give us some holes there, we can put a bar that goes down to the. We could just attach like a piece of Vex metal or some, little tube that then rest on the bumper as the intake is down. We can just make a quick hard stop, but we need some holes so we can just quickly mount to it instead of us having to drill holes into those intake plates. So yeah, it's kind of the idea of like if you scatter this thing with some more holes for us, it's going to make it a lot easier for us to prototype it. So
Josh was also talking about on Saturday putting a fourth roller where you have like the motor plate right now on the intake bar. Because like as it is, the distance from where we've had that axle that goes all the way through on the actual drivetrain to the last roller is pretty far, and he was saying it would probably help like push it over fully. So you could do that with like vortex on one of those sides, and then just run an axle, and then put your intake roller on that. That would be too hard. It would definitely help get the ball over that axle.
Yeah, doing something like that. Greg and I was also actually discussing something like that where we put a vortex up here, and just have another axle that just goes all the way through. Because you can do that with the vortex. You put some wheels on it if you wanted to try something like that.